Hello and welcome back to another episode of Advanced RC Adventures. A2RC here. This is a channel where we investigate, explore, build and explain, upgrade and advance Nitro RCs to another level. Come start a new adventure with me. Today we have another great engine overview for you today. We have another HPI Racing Nitro Star High Performance. Today we have the G3.0 HO High Output engine with pull start. This is another Force engine built by Force, dubbed HPI or built for HPI. Very similar to the G and the T 3.0, but this is a high output version. There are a number of differences between the normal G and the HO version that we're going to explore today. And this is probably one of the first Force engines that I'm actually a little bit disappointed in for the build quality, the fit, the finish, and the cleanliness of the build. So let's break into this box. This is a brand new engine and let's start the adventure. We have our engine here in our bubble wrap. We have it in our sealed bag. Let's open things up here. Again, this is a brand new build. It has been cleaned, has been lubricated, inspected, and that's where the decent amount of disappointment comes into play. So this is an HO version. Notice the similarities between the normal G3.0 and the HO, but there are some distinct differences, and we're going to talk about those distinct differences. Let's do a little walkthrough here. Let's start at the pull start. The physical pull start in the housing for the pull start is actually very different than the normal G3.0. This utilizes a fourth bolt holding on this style of pull start, and the normal G3.0 has a little bit different styling. So, like all of our engine overviews, we're going to take off this carb, have a little review, going to go through things and have some fun doing it. So off goes the carb, we'll go through the back plate and then our head. This is a typical or a standard 6mm pinch bolt. Take off our carb here. This is not the same carburetor that's on the G3.0, the slide version. This is different. A normal butyl O-ring there and an additional one here. So that is nice that there's a dual seal on the carburetor. This has a lot of composite features but some also metal features. This is a slide carburetor, as you can see. We have our idle adjustment screw there. High speed here, low speed there on the arm. And first and foremost, I want to start talking about some of the disappointment. So this particular carburetor, like every single engine that I buy brand new, it's completely disassembled. And this particular engine is a perfect example about why you really should do it. I don't want to get into the semantics of it should come to you perfect and you should not have to disassemble and clean and inspect it. I agree. But because of things like this, it forces all of us in the hobby to do a little bit more. And honestly, it's not a bad thing. It's actually kind of fun. You get to become familiar with your components and the engine itself by taking things apart and doing that inspection. So the internal components of this carburetor were dirty, but even more so when I took apart the high-speed needle assembly here, I actually found a lot of brass filings. When they made the threads inside here for the high-speed needle, when you take out that high-speed needle, there was brass all over the place. And that's really disappointing. That can clog or even worse, potentially get down inside of the engine, and now you have raw metal down inside the engine eating things up. It's now perfectly clean. Everything seems to have gone back well together. We did some moly coat and some oil in places where we need to. It should be a decent running carb, but I have yet to run this HO version compared to the G. That's something that we can do in a later episode. but this is one of the main characteristics on how this HO, this high output version, is different. The G3.0 is a 6.5 millimeter bore. This is a 7 millimeter bore. So let's reach down inside there and give it a little bit measure. So notice this is a 7 millimeter internal bore, or at the venturi. So that makes it a 0.5 millimeter bigger. But otherwise, it has the same effective neck here, so the similar amount of airflow, but the bore down inside is larger. Let's come back over to the block and let's pop off this back plate. This is one of the distinct differences between the HO version as comparison to the G3.0. This uses a larger one-way bearing for the pull start. This particular one is a 14 millimeter, and I believe on the G3.0 it uses a 12 millimeter. In addition, the way at which it goes onto the starter shaft is different. Now, it's a different part number, it's a different part altogether, but you can notice that the bearing itself protrudes out the back here. But on the G3.0, it's a smaller hex, it's the same size starter shaft, but that silver portion of the bearing actually goes forward, whereas on the HO, it goes in return. So that means that that one-way bearing is reversed in comparison to the G3.0. Let's take a look at the back plate itself here. The back plate is exactly the same between the G3.0 and the HO version. The starter shaft is as well. So let's go ahead and pop that off there. Let's give one of these back plate screws a little measure. These are an M2.5, so that's very typical. And it's 6.5 to 7 millimeters long, so that's a very, very typical backplate bolt. So let's go ahead and give it a little rock and a little bit of twist and work out this backplate and starter shaft. Same exact style starter shaft and backplate, has a butyl O-ring here for a seal as the G3.0. So we have reviewed this more in depth on how the starter shaft works in that G3.0 video, so feel free to go check that out. At the same time, there's a pin and spring down inside. We have our pin. Let's take a look at the internals here. And let's continue on breaking this down. Let's go ahead and take off the head. Let's take out a head bolt here. And let's give this a little measure and have a very small chat about this. So this is a M3, and that's great to see, have a little bit more robustness of the bolt. And this is 11.5 to 12 millimeters long. The head is effectively the exact same, and it has this matte finish aluminum, cast aluminum head. Now, as I understand it, this head button, it has a different part number, and it's a little bit different. Maybe it truly is different. Maybe the combustion bowl itself has been redesigned, or maybe a little bit bigger, maybe a little bit smaller. I'm not sure. But something that is different are the head shims. The shims themselves, the exact same part number, but on the HO version, we have two. So these should measure out at a 0.2, and they do. This is a 0.2 shim, and we have two of them. And that is a distinct difference between the HO and the standard G. The standard G has 3 of these, where the HO version has 2. So that's effectively what I talked about in that G video, that I would be removing that third one and just have the 2 shims, since that third shim would actually add a lot of gap or space in that combustion chamber. And so the HO version, it's not surprising that they only have 2. So that's definitely a difference as well. Let's come in here and let's take out our piston. We're going to talk about this sleeve and take a look at it, even do some comparison to the standard G here in just a little bit. Let's take out the piston itself. This is another piece of that puzzle that I was kind of disappointed in this Force engine. When I first took this piston assembly out, it was actually really difficult to get this connecting rod off. Yes, there are times where when you need to try to get that connecting rod off that journal down inside, it is tough. It's supposed to have a tight clearance, and that's understandable. But after I got it all fully apart, I found out really what happened. So this uses a SG shaft. It doesn't really matter what style shaft, but what's going on. And when we take out this crank, I'll talk a little bit more. The crankshaft itself was actually a small amount set into towards the center of the block, and it needed to be pushed out further. So what was happening is that when that piston connecting rod was trying to come off that journal, it physically didn't have any additional space to come out because the connecting rod itself was pushed out as well. It wasn't until I was looking around and I went ahead and I got something down inside because I was just trying to figure out what was going on. I hit it with a small piece of wood and it set the crankshaft forward a little bit, that the connecting rod popped off like normal and I was able to get it out. The piston assembly itself is the exact same between the T and the G3.0 and the HO version. So if you want to know a little bit more about that, feel free to go to check out one of those additional engine overviews. Now, a tool that comes in handy sometimes, and they make these for small blocks and they make these for big block engines, is this is a connecting rod puller. What happens is that you put this around the connecting rod down inside of here, and you spin in this portion of the threaded shaft. It's basically just a bolt on this version with a machined end. And this piece pushes on that journal piece while effectively pulling that connecting rod off of that journal. It's effectively like a little bearing puller, but it's made for connecting rods. This is not something that I use very often. Most of the time, things are lined up and you can actually get those connecting rods off relatively easily. But what I don't want you to do is use pliers or something else that actually can harm this aluminum connecting rod, or harm the bushing, or harm the crankshaft. It's better to have this tool and only use it once or twice in those weird situations and save the connecting rod or the engine from harm. So having something small like this in your arsenal of tools is something great to have. I just wanted to show you and give you a little insight on what this is and what it can do for you. So let's bring in our push block and let's get this crankshaft out of here. The reason why I had to bring in that push block was part of the other fit and finish kind of frustration that I had with this engine. The crankshaft itself is the exact same SG crankshaft as the G3.0. But the tolerance or the polishing that they did on where the bearing journals lie, they were slightly big. So what I ended up having to do is polish these portions of the crankshaft with some 3000 grit sandpaper and some oil, and then cleaned it all up to get a little bit better fitment or clearance between that internal bearing down inside of there, because otherwise the crankshaft would not want to come out, and it was very difficult to put that crankshaft back in. So we've got that cleaned up now. I just have to use a slight amount of force after I cleaned up this crank now with the push block, and it's more normal. But that's another sad kind of thing, that for this little bit higher dollar engine, this HO version of the G3.0, I had to do that. Now maybe your HO version or your G3.0, you don't have this. This is a manufacturing or an assembly error when they're making these engines from the manufacturer, and it's just something that Force needs to address for these particular engines. Let's take a look at the block here just a little bit more. We've got a side exhaust engine. We've got HO little sticker there, which makes this block slightly different than the G3.0. Otherwise, it's effectively the same. HPI sticker here, power down below. It uses the normal auxiliary engine mount flanges. There's no integrated flanges on the bottom. And it uses standard chrome steel bearings on the back and the front. Something that I would definitely change if I was a part of this engineering team is this front bearing has a seal, or a shield I should say, on the front and back. And that's definitely something that I've seen manufacturers do more so nowadays. But I definitely would recommend taking out that back seal for here. I understand that the manufacturer may want that to be in there, and we're going to run this engine as they put it in, but when it's time to replace these bearings down the road, we're definitely not doing a double shield. And the back bearing is what you would expect. It's the exact same for the T and the standard G 3.0. This block was extremely dirty. Everything's been cleaned. You should never have a Q-tip looking like this when you are swiping it in and around your internals of your brand new engine. I've found metal shavings. I've found all of this dirt, grit, and grime inside of the block. It's now been completely cleaned and everything is good now. But if you run an engine like this, you might think, oh, that little bit of dirt's okay. All that little bit of hair or small metal shavings are no big deal. In the short term, yes, your engine will still run. It will be okay for a period of time. You get one of those metal shavings in between the cylinder wall and the piston here, and it's going to be no time at all that you're going to have a giant score on that sleeve or inside of this piston, and you're going to start losing compression. It happens quicker than you think, and the longevity will definitely be diminished. Take the time, even if you're new at this, take the time to learn, get the tools, disassemble, figure out these engines. Watch videos, do whatever you got to do, but it's important to understand how these work, how to clean them, how to maintain them. There's no reason why some of these engines can't last 15, 20 years with some general basic maintenance and be in service that long. But it starts from the very beginning. The old saying is garbage in, garbage out. If you don't take the time to take a look at your internals and clean and lubricate and inspect, then the longevity of your engine is definitely going to be less than what it could be. Let's get off that rant, but it's just something else that I wanted to mention. All right, so let's hop over to here, our meat and potatoes and our sleeve. Now this is an exciting Force 18 sleeve, and this honestly is how all of these 18 engines honestly should look. Let's start with our exhaust window. This is a lot better shaped than just a simple rectangle. There's no dog ear, but take a look. We have our bevel or angle here, and it leads to a little bit more outflow from the cylinder to the exhaust. It's just a lot better shaped window than just a simple rectangle like the standard G and T 3.0 have. This is an ABC construction, so we have aluminum piston, we have a brass sleeve, and it is chrome lined for durability. So let's go on over here to the transfer port. Nice big transfer port. There's no fang, but we do have a lower bevel, and the exact same thing on the other side mirrored nice and big. It has a beveled edge here on the bottom, which is nice, leading us to our boost port. Take a look at this boost port. Nice and big leading edge or bevel. And this leads us, let's bring over the standard G3.0 boost port. These are both side exhaust engines, and take a look at this crazy difference. The entire internal diameter of the cylinder are the same. Let's go back to the boost port. Extremely different. Yes, you can definitely dub this HO as high output when you have designed and machined differences like this. Let's go over to the transfer port. Much bigger transfer port. This has a nice leading bevel there on the bottom, but take a look at the size difference between the HO and the G3.0. And then round it off to the exhaust window. Just those simple little touches on the exhaust window will add up in the end. What a crazy difference that an engine can have when you compare one version to another. I hope you like these style engine overviews, especially when we get to do a little bit of comparison between sister engines. And it's pretty normal for manufacturers to do something like this, where you start out with a standard, for example, or a Novarossi C12, and then you go up to an LR3 or something more race related or club race related. And even if they might have some similar components, they definitely can have extreme differences. Feel free to like, share, and subscribe. And if you like 10 scale, Nitro, and especially touring cars, then this is a place to be. And thanks for taking the adventure with me.